Okay, hey guys, let's take a look at the derivative of arccosine. I thought it'd be beneficial to start off with first thinking about what arccosine actually is. So it's the derivative, or sorry, the inverse of cosine, right? So whenever you see an x comma y coordinate here, you'd flip it, right? So instead of x comma y, it'd be like y comma x. So to demonstrate, for cosine, it has this point here, 0 comma 1. So then on arccosine, it would have the point 1 comma 0. So the graph kind of looks a little bit weird. It's kind of like this. But effectively, you just keep on flipping over the coordinates. So that's what it looks like. So now that that's out of the way, let's start actually deriving this thing. So I don't know if you guys saw my earlier video about deriving arcsine, but it's super similar. So the first thing that we're going to want to do is, this should be a -1, so I'll just make a -1 right there. Right, cosine -1x is the same as arcsine, or arccosine, excuse me. So the first thing we want to do is we're going to want to take the cosine of both sides, because if you take the cosine of the inverse of cosine, you're effectively doing nothing, so we can get this x by itself, right? You take the operation of the inverse of the operation, then like that cancels out, right? That makes sense. So let's take the cosine of both sides, which yields cosine of y equals, well, what's the cosine of the cosine inverse of x? That's simply x. Sorry if that was a mouthful, but kind of just think about it slowly. So now from here, we can actually start deriving something. So the next step will be to derive from here. So we'll derive cosine of y using the chain rule, because we're deriving with respect to x, so you can't, or you have to think about the chain rule like that. So let's do outside in. So cosine of y with the derivative of cosine is negative sine. So negative sine y. And then to multiply by the in, derivative of y is just dy dx, which equals, what's the derivative of x? Well, it's dx, and what happens when you divide the same thing by itself? It's 1. So I'll just write dx here, but for in the future I'll write 1. So now, in this situation, we're going to want to find what dy dx is, right? Because you want to find the derivative, so you'd want to figure out what dy dx is. So I'll switch to a different color. Dy dx. So how are we going to get dy dx by itself? We can pretty much only do one thing, which is divide this guy to get him on the other side. So dx, remember, that just equals 1. So we'll just write that as 1 from now on. So this just equals dy dx equals 1 over sine y. And then we cannot forget about that negative. So we'll just throw them over there. Okay, so in this situation, we have to use the triangles that we used in geometry. So it's coming back. So the thing we have to do here is, in this position, we really can't do much, right? Because if we wanted to solve for sine y, to maybe think about putting y in here and then solving using SOHCAHTOA, right? SOHCAHTOA, I'll write it up here. We get kind of stuck. So we have to think about where else we see an expression like that, and we actually see one in our first step where we take the cosine of both sides, where we have that cosine of y equals x. So let's think about the cosine. It's adjacent over hypotenuse. So adjacent over hypotenuse has to equal x. So we can just make this guy x and this guy 1. And that satisfies our condition. So in order to figure out what sine y is, we need the opposite. So we'll need this. So I'll mark it as a question mark. So let's use the Pythagorean theorem. A squared plus b squared equals c squared. And if we rearrange this to solve for this triangle leg here, which we'll just call b, it can be a or b, it doesn't really matter. Let's say b squared equals c squared, which is always the hypotenuse, minus a squared. So now we'll square root, and here I'm just going to add in the numbers. So b equals the square root of c squared, which is 1, so it's 1 squared, 1. And a is x, a squared is x squared. So b equals, so this side length equals 1 minus x squared. But don't forget the square root. Okay, so from here, we're really close to finishing up. So we know what sine y is now, because we can just think about our expression. So sine y in this situation I'll just write dy dx equals the negative 1 over, and we just have to put in sine y. So what's sine y? Remember, opposite over hypotenuse. The sine of y equals the square root of 1 minus x squared. And the answer is over 1, but for simplicity, I'm not going to put it over 1 because it's the same number. So this ends up being our answer right here. I hope I helped.